Okay, yeah, today I'm going to talk about peer-to-peer network. So I noticed previously you guys haven't been given a chance to ask questions. So for my talk, you can stop me anytime and ask questions. We can have freestyle discussions. And also, all the views in this talk are just my personal views. It doesn't reflect the views of any organization. Yeah, so a bit introduce on myself. I'm now working in Uber, and so before that I have been in a startup and Google. So I know because now all the big companies use centralized systems for all the data processing, machine learning, or whatever. And in my PhD study, I work on peer-to-peer network. It is the underlying network of the blockchain. If you ask any blockchain, if it doesn't use peer-to-peer network, it is not blockchain. So next time when someone say, okay, I'm a blockchain company, you ask whether they are using peer-to-peer technology. So it's kind of like I know the way I have the experience and can learn the two sides of the coin. So in this talk, I'm going to dive into the basics and the fundamentals of peer-to-peer network. No fancy words. You can forget anything about smart contract, proof of work, proof of stake, any jargon about a blockchain, you can forget it. And we look at the peer-to-peer network and try to see the fundamentals and how it works from the basic intuition. So this is the homepage of Seele, and when you look at it, on top there's a GitHub. When you click to the GitHub, you will go to the open source code. I have read the code, so in the code there's a folder called P2P. That is the abbreviation of peer-to-peer. So you go to the code, you will see peer-to-peer. So that means this is a blockchain technology, right? So, yeah, that's so the first question you will ask, what's a peer-to-peer network? So it's kind of like blockchain. We have a lot of fancy words, a lot of terminologies, but what's the fundamental? So the fundamental is a peer-to-peer network. So then the first question you may ask, what is a peer? And what is a peer in the peer-to-peer network? So for peer-to-peer networks, it is a fully decentralized network. There's no servers, no coordinators of the computer nodes, so it's fully decentralized. So also it's a network. It's not an application. You can run anything on this network. So you can run blockchain, you can run file sharing, video streaming, anything. And it's self-organized. By that, it's similar to decentralized. Because it's decentralized, so how does this network organize? And so it is self-organized by peers. Then we come to peers, and what are peers in this network? It can be any computer, any fancy ASIC, and any computer resource. It's a peer. You can use your mobile phone, that's a peer. You can use your personal computer, that's a peer. You can use fancy technology like GPU and ASIC, that's also a peer. And so it's a computer resource. Any computer resource is a peer. And so then the question is for example, in this picture we shows, on the left side, it is a centralized application. In the central, it is a server. This server controls everything. And it controls how the nodes communicate with each other and how they connect with each other. On the left side, it is a peer-to-peer network. Each node is a computer. You can think of it as a peer. So each node is a peer, and they connect with each other. They communicate with each other. So there are two sides of this network, peer-to-peer network. First, how to connect with each other. Second, how do we communicate with each other? So for the first part, it's more like network construction. It's like human society. In human society, I make friends with my classmates, my colleagues. It's kind of I have some local connection with this society. And then how do I communicate with this society? Nowadays we can, read newspapers, read like Facebook, Twitter, Google, search, and we can do everything online. But let's say in the very like old ages, without TV, without anything, we have to communicate with our friends. And there are two things here. How do we make friends? How do we communicate with our friends? So these are two things that happen in human society. It's also happening in the peer-to-peer network. So this basically shows the basic idea. So how do we achieve this? Gossip is everything. For example, in a local community, if there's something happening in one family, friends of this family knows this news, and then the friends of friends. So it's just basically gossip. How do we make friends? Okay, for example, I know my classmate, and my classmate introduced me to his friends. This is gossip. So the gossip solves everything in the peer-to-peer network. It solves how do we connect and how do we communicate. So it's very important. And so let's go to the first part. That is how do we connect, the network construction. And it's a fancy word. And so network basically is, for example, one computer connect to another and then connect to each other and formulate the whole internet. That's network. But when we go deep, there are only two things. How do we join this network? How do we leave this network? And when we join, what happens? When we leave this network, what happens? So that is peer arrivals and peer departures. For like a peer-to-peer network, in terms of network construction, let's say there's already like a network of 1,000 computers. And I want to use my personal computer and join this network. The first thing happens in a peer-to-peer network is to ask this network, any node in this network, give me a list of peers in this network. And I use this list of peers and try to connect with them. And suppose, let's say, I want to connect with 100 computers. But in this list, there are only 10 computers. So I connect with them, maybe 2 of them failed, and only 8 of them succeeded. So I asked these 8 computers, could you give me more other peers? Then I gradually built connections with 100 computers. So that is basically peer arrival. How do I join this network? And for peer departure, it's similar. It's kind of like, let's suppose now I have 100 computers connected with me. And then I suddenly notice one computer left this network because when I send data to this computer and there's no response. So that means it left this network. So how do I let like other 1,000 computers know this has happened? I just broadcast this information to all the other 99 computers, and they will broadcast further. And then the whole network knows what's happening, and so the whole network knows, okay, this computer has left this peer-to-peer network. So it's basically it's very simple. It's kind of like human society, and so for example, like in a company, when one friend left the company, I told my friends, and then my friends told others, tell others. So we know like how we build this network. So kind of like this picture shows a simple visualization of the network. It's kind of like we randomly pick other computers to connect with, and then we have this graph. Is kind of each node is a peer. Each connection means I'm connected with that computer, and so it's kind of like random, and there's no structure in this network, and there are good things about this network. It's resilient. What do we mean by resilient? It means if some computer left this network or something bad happening in this network, it's okay. For example, if this node is 68, if it leaves this network, it only impact all the nodes connected, all the peers connected with number 68. And there's no big impact to the whole network. So that's one advantage of peer-to-peer network. It is resilient and it is fault resistant. And so, but this is not the only topology we can build with peer-to-peer network. There are a lot of different types of topologies. This is just the random graph topology. And so when we change the way one peer connect to others, and then we change this graph. That's to look, this is one extreme of the example. Let's look at the other extreme. So this is more or less like a centralized network, because you look at the number 0 on the top, this is 1, and that is 2 and 4. These are and 3 in the center. So these are very important nodes. For example, if number 1 left this network, and all these other nodes will be impacted. But still, it has some advantages. For example, when in a random graph topology, when number 90 want to connect with the node on the top, it's hard. It will communicate with its neighbors and propagate, and it's kind of need more steps to connect with for these two nodes to connect to communicate. But for this structure, let's say this node want to connect with communicate with the node on the top. Only communicate with number 2 and go to number 0 and then communicate. So it's easy. But the thing is, this topology is not like fault tolerant. Let's say number 1 or number 0 want leaves the network. It's not centralized. There's no centralized control, and they can leave at any time they want. So this will have a huge impact over the network, not only like in terms of network construction, but also for the data exchange. And so this is these two are just two extremes of the topology. There are many others. Depends on the application. We may have a very smart choice, like how to strike a balance, for example, between this structure and the random graph structure. That's a very tricky problem. So we arrive at the conclusion: peer-to-peer network is resilient. And let's go to the next step. We know how do we build the network, how to connect, but how does the data propagate? It's simple. Actually, we have already discussed. Like in the network, we just propagate the message across the network, step by step, through our friends, through our neighbors. So it's kind of like human society. And so but here there's an issue. For example, if in a centralized system like Google, Facebook, and they can do anything with the data, and also the servers, they can design very fancy, advanced architecture to scale the system. But in a peer-to-peer network, there's no centralized control. How do we scale the system? And that, so let's say by scale the system, I mean like, let's say today in this network only 10 computers, but tomorrow we want to support 10,000 computers. How do we achieve that? So mathematically we already proved that the number of steps for messages, the average number of steps. By steps, I mean, for example, if I send this message to my friend, that's one step. My friend sends to his friends, that's another step. So the average number of steps is log of n. So everyone, I think, familiar with log. It's kind of like, let's say, 10 power 4. That's only 4 steps. So it's pretty scalable. And another thing about the peer-to-peer network, also surrounded with the so-called decentralized. It's censorship resilient. What do you mean by that? Let's suppose some organization very powerful, like government, they want to stop this network. It's hard because peers are distributed across the globe. Let's say today US want to ban this network. Some nodes are in Europe. And also in terms of data, because the data is distributed across the globe. I have 1 copy, you may have 1 copy. So if US ban all the nodes in US, the nodes in Europe still have the data. So another thing is about censorship is, let's say Facebook control everything. I don't know whether you have listened to the hearing of Facebook, but it's an interesting topic. And that means Facebook has all the data. So it's kind of dangerous. But in a peer-to-peer network, no single computer has all the information. It only has a partial information, but how to combine them, how to use this information, and how do peers collaborate with each other, communicate with each other. And that's the power of a peer-to-peer network. So we live in a real world. So whenever we get something, we have to pay something. So what do we lose in terms of decentralization? Of course, no centralized control. And that means peers are selfish. Because behind each peer, there's a person. People are selfish. So they want to game the system. Let's say I send you data. Is this data verified? Is this valid data or invalid data? So this is the core problem of peer-to-peer network. So peers and people need incentive to cooperate. By cooperate, I mean like they follow the protocols, the rules of the network, instead of play against the system and distribute some rubbish information, or wrong information. But it's hard because there's no centralized entity to control and to enforce these kind of things. I have spent 4 or 5 years on this topic, so it's a hard problem, and I think everyone has their own perspective of blockchain. In my perspective, the blockchain, it is an incentive mechanism. It motivates people to be, truthful instead of cheat and play against the system. Why is that? Because of course, secure, incentive, censorship, resistant. So these are the benefits. So secure and censorship resistance, these are the benefits we can get from a peer-to-peer network. And the blockchain provide incentives. That is let's say, in Bitcoin, why people want to join and join this Bitcoin network? Because there are transaction fees, right? And why don't they want to play against the system? Because there's no benefit. If they play against the system, they lose instead of win. So that's why incentive is important, and that's my perspective of the blockchain. It's kind of like human society. For example, if a student from Stanford and he wants to go to the job market and find a job, I think he will quickly get a job. Why is that? Because there's a mark there. You are certified by Stanford, right? Why the Stanford certificate or degrees are important? Because you have to do a lot of work to get it. Not a lot of people can get it. Only a very few top people can get it, or lucky people can get it, or people who are used to this system, this education system, anything. but it's a rare and valuable resource. You have to spend such amount of resource to get it. It's kind of similar in like Bitcoin. It's so-called proof of work. If you want to verify something in this network, you have to spend a lot of computation resource. And it's hard to cheat. So that's why proof of work is important. So yeah, thank you. So that's a very intuitive talk, and I don't know whether you guys have any questions. So